A very warm welcome to our viewers. As the world becomes more and more driven by technology, we are beginning to recognize the need to be conscious about using technology efficiently. This is especially true for industries and plants, which use massive amounts of machinery requiring huge amounts of energy and other natural resources. It is in this scenario that the efficient use of energy becomes imperative.
Bureau of Energy Efficiency, working under the aegis of Ministry of Power, has been working relentlessly towards energy saving and its optimal use. For this purpose, it has launched the PAT scheme, under which it has identified energy efficient technologies across industries. In this episode, we bring to you the benefits of waste heat recovery system for hot water generation in place of low efficiency air compressors in the textile industry. The measure, which can be a game changer in the textile industry and the world, uses a system of low-grade waste recovery for energy saving and water conservation. In modern textile industry, about 11 to 22% electrical energy is consumed by air compressors alone, which are low-efficiency devices consuming a lot of power and water. This was a huge potential area for bringing in energy efficiency, which has been addressed by the new technology implemented by one of the designated consumer in PAT scheme. By replacing all old centrifugal HT compressors with waste heat recovery system for water generation, considerable energy and water was saved, as well as reduction in carbon footprint was achieved. Let us see how. In an air compressor, a lot of incoming electrical energy used to get wasted by losses due to radiation or condensation heat. In the new system, 90% of this input electrical energy is converted into waste heat, which can be utilized by providing heat recovery unit in the compressor and recovering this heat from each stage of the compressor. Also, a provision of collecting hot water in the common tank has been made, which can then be distributed throughout the plant for various applications. This results in electricity and water savings. The usage of cooling towers for air compression has been completely eliminated, thus resulting in more water and energy conservation. Low-grade waste heat is recovered for preheating water for boiler and other processes, and significant reduction in specific energy consumption (SEC) for compressed air is achieved. The recovered hot water can be used for feeding into process machines or to boiler. This project also brings with it some tangential benefits like reduction in electrical power because of the elimination of cooling towers and coal consumption of the plant as it got waste heat for boiler, less startup time of process machines and improvements in feed water temperature of the boiler, along with reductions in greenhouse gas emissions.
Heat recovery unit in the centrifugal compressors, we have utilized the basics of the physics wherein the 90% of heat rejected in the centrifugal compressors. So, we are utilizing that rejected heat by the meaning of installations of the heat recovery unit in the centrifugal compressors. We are recovering in the tune of 70 degrees Celsius from the centrifugal compressors and thereby utilizing it in the feed water of the boilers and in the process machines.
The benefits accrued of this technology far outshines the cost implications. In the case of Raymond Yuko Denim Limited, a total of 3 waste heat recovery units were installed, 1 complete and 2 partial at the cost of ₹90 lakh. This seemingly big amount is soon overshadowed when we look at the savings. The total annual cost savings derived out of this project have already amounted to ₹99,92,400, which is more than the investment on project implementation. Power saving worth 4,89,744 kilowatt-hour per year has been achieved. Coal consumption has been reduced by 1,800 metric ton per year. The amount of water saved alone has resulted in savings worth ₹3,43,680 annually, with 17,184 cubic meter of reduction in water consumption, thereby reducing not only the financial excesses but also the environmental losses. And to top it off, an annual reduction of 5,432 metric ton of carbon dioxide emission has been achieved.
We are very particular about the energy conservation, sustainability and environmental conservations and all since our beginning. PAT 1 and PAT 2 process, we have achieved around 6,125 e-certificates. Things has changed a lot, and now I think this has taken a shape. This has taken a momentum, and now everybody is quite conscious about it, because if it in today's condition, if we see the main area where we can save some money and we can save some business factors, that is only area is energy conservation, environmental conservation and all this.
A small change can sometimes set the ball rolling for bigger changes, and this initiative in an intrinsic process of the textile industry can have a huge impact if replicated on the larger scale of the entire textile industry and other similar industries where this process is used.
Apart from being a world-leading sector, textile industry is also one of the leading power guzzlers in the country. The usage of low-grade heat recovery system for HT air compressors is a step in the right direction to ensure that the textile industry becomes niftier by becoming more energy efficient and less water intensive, while also reducing its carbon footprint. That is all for now. In our coming episodes, we will be back with more energy efficient technologies. Till then, goodbye.